So, have you ever wondered what happens when a star dies? Now, stars like our sun will die gracefully. They'll fade and produce a white dwarf. But this is not the case for stars which are at least 10 times the mass of our sun. Now, when they've burned through all of their fuel, they're unable to support themselves against gravity. And so, they collapse in a violent explosion called a supernova, leaving a black hole or a neutron star. Now, these explosions release more energy than the sun does in its entire 10 billion year lifetime in a matter of seconds. And to understand these explosions, we want to find them. And how do we do this? Well, we use telescopes to look at very nearby and massive galaxies, just like this one on the left here, because you're more likely to find a dying star in a galaxy which has many, many stars. But there's a problem with this strategy. Doing it like this, we're biased towards the most massive galaxies. So, what may we be missing in very tiny dwarf galaxies with very few stars? Well, this is what we've been trying to remedy by using enormous cameras to look at huge patches of the sky, just like this one. And every blob is a galaxy. And so using this method, we're looking at galaxies big and small at the same time. And we found supernova in these tiny dwarf galaxies with few stars. But even more remarkable is that they seem to harbor a totally unique kind of explosion, which is 100 times brighter than an ordinary supernova. A superluminous supernova. And this is the first one we've discovered with our new survey. In the blue is the galaxy, and on the left, in the yellow, is the superluminous supernova. It completely dominates, but we don't know why they're so bright, and we don't know why they're only found in tiny galaxies. And with these large samples we're getting from telescopes, we're going to compare the environments to basically understand the differences to why these are only found in the tiniest galaxies in the universe. Thank you.
Thank you, Kirsty. Thank you.